Today we're going to use the Atwood machine to talk about system forces. The Atwood machine is really just a pulley with a couple of blocks. In this case, a 2 kilogram block and a 4 kilogram block. So we'll look at what is the resulting system acceleration and what is the tension in the rope. Now, you could look at the tension as being above the 2 kilogram block, and you could look at the tension above the 4 kilogram block. But because it's one rope and it's in tension, the tension at A is the same as the tension at B. We'll just call it tension. And with regard to a system, that's just really objects connected together, such as these two train cars, A and B, so that at any given time, the velocity of A is equal to the velocity of B, or the velocity of the system. At the same time, at any given time, they have the same acceleration. So we're going to use our acronym, which is Fantasy Football, every Sunday. And you may recall that the first F is for frame. Now the frame in this case is going to be clockwise, because if this moves at all, it's going to move clockwise. And the second F is for force diagram. So this is the diagram of the forces on the moving part, which is the rope with the two blocks attached. So we have a 40 Newton and a 20 Newton gravitational force and a 60 Newton reaction force at the pulley. We might be tempted to add the tensions in the rope here, but they're really internal to the system and they would simply just cancel out anyways. So our equation is F net equals MA, but because it's a system, we're going to use the system for both M and for A. So when we get F net, we get it from the diagram. 40 is going with our frame, so it's positive. 20 is going against, it's negative. The difference between the two equals our mass, which is going to be 6 times the acceleration of the system. Solving for the acceleration of the system, we get 20 over 6, or 3.33 meters per second squared. And because that's positive, that tells us that we are indeed rotating clockwise. Now, to find the tension of the rope, that's a little bit trickier. As we know, they are an internal force pair. So we're going to need to isolate. We can't use the whole system because we know they will cancel. So we're going to isolate, in this case, on the 4 kilogram block. And we're going to make a force diagram of just the 4 kilogram block. And we have tension going up, and we have the 40 newtons down. We're tempted to say the tension is equal to 40, but that would only be as if we were holding it still and not letting it accelerate. But it is accelerating. It's accelerating at 3.33 meters per second squared because we already found that. So this time when we do F net, we say 40 minus the tension equals the mass 4 times the acceleration, which we've already solved to find. It's 3.33. And the tension is going to then be 26.68 newtons in the up direction. And that makes sense because the difference between the tension and the 40 is what's